Hi, everyone. I hope you can hear me well. I have to say, this is the first time that I'm giving an hour and a half talk. I don't know why. I said I will take an hour and a half. Other people took an hour, so I hope it won't be boring. I tried to put this thing is not a picture. We actually glued it to the wall. I really like to travel, and it's really depressing enough too. But anyhow, we have an hour and a half. I'll try to not take your whole afternoon. And I will talk about Argo. I will try to, Argo contains of really a bunch of components. As Giuseppe said, I've been working with this system for really, really old times. I think a few of you have been here for so long. And it's basically, it's a system that's slowly evolved, and it's still evolving. So I'll basically present how it looks like right now. I won't have enough time to go into future plans, as we are now kind of working on them. So I'll focus on what we have right now. Argo is a product of three institutes. So three institutes are working on it. It's GRNET, SRCE, which would be us from Croatia, GRNET from Greece, and CNRS, Cyril from France. Here are the current names of the people working on the project. So, as Giuseppe said, Argo is the official monitoring system in EGI and IOSC. So what does that mean? Is this thing switching right? I hope you see the slides. So I'll have a short overview what Argo is, which will take most of my time. And I'll really try to explain you every component and emphasize the ones which are important from you, either from the perspective of a service, if you're a service provider, or if you're a researcher / user, or if you're planning to onboard your service. So with regard to the perspective of onboarding new types of services, I will point out at the end relevant procedures that need to be followed, and I'll describe the general integration procedure that we follow in Argo. In the end, there's a bunch of links that you can then use to read yourself later on if you don't get everything from me. So as Giuseppe said, the slides will be publicly available later on, and we can go in what Argo does. So EGI, I'm not going to describe what EGI is. So you can imagine a bunch of services laying in different countries, and then distributed over different institutes, and then handled by different group of people. So the point of Argo is basically to continuously check how these services are behaving in order to provide availability and reliability reports. So as most of you know, if you had any experience with EGI, these NR reports are basis for the SLA/OLAs that we all have to sign once onboarding in whichever role to EGI. So basically, the Argo provides this functionality of monitoring all this whole distributed system comprised of different service types, so different functionalities, different users participating in different roles. And how it works is basically right now there's the two central instances which are based on the different service types, service flavors. It just goes and checks from the central instances if the service is behaving as it should. So that's one really important thing, and I will repeat it later on, is that the Argo focuses on the status monitoring. So Argo is not your fabric monitoring solution. Each of these little sites, little tents that you can see are basically expected to have their own internal fabric monitoring. So a very, very long time ago, with a different group of people, we were actually planning to integrate the site's fabric monitoring system in this big system that was supposed to provide availability reliability. And our whole idea was that we would enrich it with the Fabric monitoring data. People will have better view. But then, as experience showed, it didn't really work. I think I saw Sven. So as a security guy, he would say, "Oh no, the Fabric monitoring data is something that is private to the site, and you do not expose it outside." So that's very important to remember. Argo monitors things from the outside. So it basically mimics the users, and it gets the user experience of the services that it's supposed to monitor. So we do not install any kind of agents on. So if you're going to provide a new service, either a web server or something providing some capability like computing or storage, Argo will only test how your service is functioning from the outside world. So that's very important. Now, so the basic idea of Argo monitoring is not to paint the picture of trends, how fast is your service, but rather to paint if your service is properly working or not. So let's say in a world without Argo, you would have a bunch of these tents and you would have users going around and trying to get some capability out of those tents. And then in some cases, they would get red. The whole idea of Argo is to spot those red tents before the users do. So that's the whole point of status monitoring. If the users call you, then your status monitoring is already broken. So that's the whole point. We go. So the Argo is supposed to catch the red tents before the users catch them. Now these are some typical examples, which then they translate into GS or help desk tickets saying, "Oh, your site is broken. How come that we're paying you to maintain your site and only me?" It took one user to figure out that it's not working. So that's why you have Argo. Argo is supposed to monitor it continuously for you in the way how you want it for a given capability, and then of course send you alarm on time. So let's say I am an admin, as I am, as you've seen from my CV. I really want to get a notification because before these poor guys land in the red tent and figure out they have to sleep in the woods because my service is broken. Now, so output from Argo, as you've seen later on in the demo, it's the reports. So either status reports, meaning real-time status reports, if you want to analyze what is going on with your services, something is flip-flopping or it's red right now, you want to get the details why it's red. At the end of a month, well, most of you probably noticed the reports that nice CGI people send out. And then, of course, the real-time alerts, that's the important bit for site admins. Now, here's the factory that does the magic. It looks really complicated. And as we like to say, once you start explaining it, it gets even more complicated. I'll try to emphasize the most important bits which are relevant for all the actors in the Argo and EGI world, and explain you how you actually fill in what you need to fill in and where you find information that you need to find. So the picture is big. I'm gonna go step by step. So two important bits that you can see on this picture are, I hope you can see my pointer. But if you can't, I'll just say it. So topology and profile. So these two things are what we call sources of truth. It's basically the databases that are describing the world that Argo is supposed to be monitoring. So because everything else is a machinery that does something, but these two things, topology and profile, are basically the core information that is needed in order for Argo to know and what do I need to monitor and how. So first up, topology. So in EGI, I apologize in advance for all of you who are already familiar with GOG-DB, but in order to fill the picture, to provide the full picture, I'll start with the GOG-DB. So the GOG-DB has been for ages the official topology database for EGI. Argo is only one of the systems which relies on the data coming out of it. There are other systems which also rely on it. And what it provides is first the hierarchy. in a sense of the organization. So if I go back to this picture, the GOCDB will contain the information which tent belongs to which institute, which are the responsible persons that are handling that tent. And then again, these two tents are sitting in which, let's say, bigger group, either a country or something else, project or whatever. In each case is a country mainly. And then who is responsible for that particular country, and then how all of these things aggregate. So that's why we have the projects. Right now there's only EGI, but GOCDB supports multiple of them. Then the NGIs are basically, this is the old abbreviation, National Grid Initiatives or infrastructures. I've never shared which one of those, but it doesn't matter. In this story, what you need to know is these are basically group of sites. So let's say you have 6 institutes in your country. So your NGI would have 6 sites, and then sites are basically groups of services. Now services are instances of what we call service type. Now service type is and I copy pasted this from the GOCDB, which is some really old definition, but it's basically certain certain functionality that the service provide. So, or technology used to provide a service, but it's the easiest way to understand it is a web server. So for example, you build an infrastructure which contains a bunch of different web servers which are providing something, and service type is basically let's say a tag or a name which describes that particular service. And then the services are basically instances of these service types. I'll show on an example later. And then there are many other things in GOCDB, but let's say these are most important for my story right now. There's also downtimes. So this is basically functionality that allows you to say my services will be unavailable for these and these reasons, like if you are going to replace a bunch of your servers, or if you're going to replace your network or power system or whatever. And then there are unscheduled outages. These are also nice if you have a sudden failure in a Sunday morning and the whole group has to go there and fix it. It's always nice in GOCDB just to put there was an unscheduled outage so that the users are aware of it. And then finally, there are users and roles. There are a bunch of different users and roles, which are not that relevant for my stories. With regard to the groups, so as I said, the NGIs contains a bunch of sites, and then sites are basically services. There's other type of groups. There's another type of grouping that you can do in GOCDB, and these are service groups. Now, this is interesting when you want to aggregate a bunch of services which are spanning on multiple sites. So, for example, in our case, Argo is being provided by 2 institutes. So there's redundant instance provided on site A and site B. And then you want to create a service group saying, give me all Argo services. For example, you would create a service group called Argo and then put all these services in it. So these 2 hierarchies are important for generating availability and reliability, as you will see later. Now I can switch the screen to GOCDB just to not show you that. I hope this worked. So when you land on GOCDB, it supports for all the older audience, it supports X509 certificates, but it also supports the AAI. Now, there's a bunch of different things, but I'll just quickly show you. So the NGIs, so these are the groups, practically countries. So I'll pick mine, so Croatia. And if you drill down, you will see sites which belong to the country, to the NGI, and then these sites together with the NGI, they can have different attributes assigned to it. They can have these scope thingies, and these are all things that allow you to do further filtering either in Argo or in the other systems which rely on GOCDB. Drill down further, FedCloud, this is our site, and then here there's more attributes which are relevant for the procedures that I will mention at the end. But let's say if your site reaches production and certified, then you're in production and certified, meaning that you will be fully monitored by the Argo. I won't go into too many of these. I won't describe every attribute in detail because once you start onboarding your services, if you need to do so, you will get familiar with them through the relevant procedures. Now, here's an example of a service. And now here's the important bit. So as I said, there are service types, and in this case, it's an OpenStack Nova. So this is basically, as I said, Apache Web Service. So in this case, this service provides OpenStack Nova instance. And then the second part is a host name. So this two information, service type plus host name, form a service. And this is basically the entity that Argo monitors. As you will see in the later part of my presentation. Now, with regard to the service types and which service types you have, it's very convenient. So you have the services tab in GocDB, and I should lost all my Zoom buttons. Keep the chat open, so somebody type me in a chat if I'm talking about something that you do not see. Now, service types. So here you can see all the service types which are already in GocDB. So this is quite important. So if you're just a service provider that is planning to install a new Fed Cloud site, for you, job is quite easy. You just follow the procedure of adding a new site, or if you're sitting at a site that already exists because it was running some HTC part in the past, like CREAM-C, ArcC, HTC Condor-C, or something like that, SRM, for example. So in your case, you will just go and add a new service in GocDB. So this list of service type is nice thing to check always before you put something in. You don't you always go and see if the service type already exists, because then your job is easy. You just add a new service of that given service type. So let me see what for example, let me find all Argo VPUIs, go to services. There's only one, and then give me all Argo ones. Services. I don't know if there's a GocDB store planned, as GocDB has many more things in the backend, which I do not have time for. So I will stop here. Share the screen. So I showed you all of these things and the important bit. So hostname and service type form a service. So that's the topology. So once you start, well, if you want to play with us in Argo, first thing you need to do is you go and get your service in the topology database. Before, if the service is not there, we can't help you. Again, as I said, the GocDB has different things. We have development instance, we have uncertified instance. So putting your service in a topology does not mean that you are immediately going to be charged if you break something there and you do not put the downtime and so forth and so forth. There are various steps in the process, but basically a message to take back home is that in order to be monitored by Argo, you need to get to GocDB first. Now, second part is internal to Argo. So POEM is a component that we developed, and now the POEM is a component. So if the topology is answering the question, what should I monitor? Profile, POEM component answers the question, how should I monitor it? Now, POEM started as a very simple thing, basically mapping the service types that you've seen before with names of the tests / metrics that are supposed to be run there. But then as in EOS Hub, we had the task of providing a one-stop shop. So basically easy way to spawn a new tenant, new Argo instance. The POEM component basically grew, and nowadays it provides everything that is needed from configuring basically how to monitor this particular service to the information on how to generate full-blown report for a given tenant slash project. Now, let's go into details. I added a link here. POEM is basically, it's a management interface. It's mainly, so editing part is mainly done by us because the procedures work in a way that you send something and then we do all the dirty work in the background. But for you, there are publicly available pages which are read-only, and these are really useful for basically seeing how the system is being monitored now, which probes are being used, and then to find further information about these probes. So we did this part. We really tried to put as much information there as possible because from our experience, the major issue was with the user was that it was difficult for them to understand when they get the critical, what does it mean? So that's why we have the public pages where you can basically go and see, this metric means that. So from the high level point saying, these service steps should have these metrics, to the point where you can basically download the code. And if the reason for the failure is not self-explanatory, you can basically open the code and tweak it and make a PR, make the probe better. That was always the idea, because the service, I mean, I started this whole monitoring system, I started contributing to it from the perspective of site admin, because at that point, the monitoring system that was in place back then didn't have a nice view for site admin. So I was always annoyed when somebody 7 days after something is broken will open me a ticket and say, this thing is broken for 7 days. So I basically started with the site admin hat on, and that's why we really try to add as much information as possible. Sometimes it's hidden, but we are working to get it out in the open and as findable as possible. That's a work in progress. Now, what do we have in POEM? Bunch of stuff, as I said: probes, metric profiles, aggregation profiles, operation profiles, reports. Now, reports are basically aggregation of all of these things. So the report is what you get at the end of a month from the EGI. It's basically a definition of which exact service types are we monitoring, on which groups of services, how do we group them, how do we aggregate them, what kind of logical operations do we perform among them, and then finally there are thresholds which are not optional. So at what point something becomes green. So for example, if you have a review, you just put those thresholds a little bit lower. Of course, we don't do that, right? But yeah, but there's an option to do that. And then, for example, weights. This is also a legacy thing, which it's not really used in all the systems, but it's a really nice functionality. The weights allow you to say this service is more important than this one. So in the Cream CE, the weights were basically the HAPSPEC values for the computing element. So to make a long story short, it's basically it's like a flops thingy if you're working in HPC. So it's a benchmark saying you are providing 1,000 something, while this little site is providing 1 something. So the idea is that when we generate the report, the bigger sites and their availability is more important. So if you have like 3 sites providing 1 worker node, if you're an HPC, and then you have one big one providing 10,000 of them, and then you say, oh yeah, this one with 10,000 was unavailable for a full month, and these 3 small guys were available full time. So you can't really say that you were 75% available. I mean, the users will not quite understand it that way. So that's why we allow you to define weights as well. Now, for all of you who came here because you are going to onboard new services, this part is interesting. I think I saw some of you who we already had the meetings with. Now, probe in in the backend part, Argo uses Nagios framework as the monitoring engine. That's why the probes, basically a piece of code, script, or however you want to call it, which is used for monitoring services, has to follow the Nagios API. Now, often I hear people, why do I need to follow this and this and this and API? It's basically because we started with it, and it's very simple and very flexible. And there's at least 3 systems that I already know of that follow this API. We are working on expanding this definition, but let's say for right now, the Nagios API has to be followed by all the probes that are onboarded in Argo. Nagios API, just to summarize, it's very, very simple. Basically, you need to have a piece of code, which once you execute it against a given service, will on the exit code return 4 different codes, basically, okay, warning, critical, unknown. And then on the standard output, it will just spit out some further details, which is always nice to give to people. You don't want site admin to get in the middle of a night alert saying critical and with an empty text. It's always polite to give them, oh, your HTTP is not responding, or your HTTP is responding with 5.0, or it's responding with some gibberish and so forth. So that's basically the API. You just put the exit code out and put some reasonable details for people to understand what is broken on the output, and you're good to go. Now, it supports any programming language. It can range from a simple ping to some kind of more advanced availability checks to what we've seen a lot that people do. They basically, for the services that provide their own internal health checks, you just go and query that particular thing to read something like JMX. So a lot of people do that as well. And then there's the synthetics slash user mimicking probes, which are more the most advanced ones. And if you remember the beginning of my story, these are the most valuable ones, because these will spot the details that your users are actually doing the service. So user mimicking behavior is, for example, if you're doing a probe which checks if the AAI service is working. So what you could do is what we've been doing, for example, in the past, is you just go and ping, oh, is this thing working or not? Oh yeah, the HTTP is saying, okay, the login screen opens and the login screen returns the string, like enter your username correctly. So we assume everything is right. But basically, you could, for the user, he can go there and enter his username and password or whatever, and then everything just falls apart after that step. So that's why if you're able to provide a more advanced synthetic test, which would basically take some kind of a test user or something with a test token and go and try to authenticate, so do the full chain of actions that the users will do, this will be much more valuable from the monitoring perspective. So, but basically, if you're a service provider or if you're providing a new type of service, it's up to you. How deep can you actually go? And then if you're a member of a research community, we are open to everyone. It's also up to you to provide something which mimics what you are actually doing with the service. I mean, honestly, we do from a simple check HTTP checks against websites to check HTTP, which are looking for strings in the output, to then we have really advanced probes which keep their own internal states. So for example, the probes which are executing jobs on a compute element. So there's a little cluster there. This thingy runs a job and then leaves the job running on a cluster, and it picks the result later on. So they have their own internal state management. So we can handle any kind of complexity. However, right now there are some limitations, which are mainly because we work hard to automate all this thing. Basically, what we have right now is that once you put things in a poem, they magically just appear on the Nagios box and start running. So that's why we have a strict requirements right now that the probe has to be installable on CentOS 7, and it has to be nicely packaged. packaged in a way that once that the automated the Ansible/Puppet mechanism just spawns a new box in Okeanos or whatever FedCloud site we're using right now, and the thing just works without any of us going there, logging in and doing manual steps. So that's why right now the requirement is that every probe has to come in a form of an RPM package, which is available in YAM repositories. So all of these things are basically entered in the POEM interface. I will show you the live demo later on. Now we come to a metric. So the probe is basically a code that performs monitoring of a given service, and then if we follow that logic, the metric is a piece of a code that does a specific check. So example would be if you have a probe that checks your web server, then one metric would be check if the server will answer HTTP, and the second one could be check if the HTTPS gives me valid certificate, valid in a sense that it's present in a standard bundle or whatever bundle we define, and that it's still valid, of course, and that it's not in a CRL and blah, blah, blah. So these are the examples. A single probe can provide multiple metrics or can have one metric. It's really up to whoever provided the probe. But then also the metric can basically, they can differentiate in a way how they are configured with regard to parameters. Let me see what I have. Okay, I'll show you a live demo before I proceed to the higher levels. So basically, these metrics, if you're familiar with Nagios, you will see that some attributes of a metric, which are basically things that we define in a collaboration with EGI operations and with the service providers or / technology providers. Now these metrics have bunch of different attributes. So let me see. I'll do a new share, and I'll go to administration public home. So this is the link that I showed before. Oh, sorry, I messed it up. Second, go to the home share. Okay. So this is the link that I showed before, and here is basically here you can see the different things that I described before. Now first we go to probes. Here's basically the list of probes that are currently available. Now the important bit is that the probes are shared among all tenants. We have multiple tenants right now. I'm showing you the view for the EGI tenant. And our idea was always that there will be probes shared among all the tenants that we provide the Argo service for. We thought that this is a nice way for people to share the stuff so that we don't have to reinvent the wheel. Of course, you're using some shared probe is not a mandatory thing. Of course, you can always provide your own because it's better, whatever. Now let's take, for example, the AMS probe, which is this is developed by us. There's an option for versioning. This is quite important when you're doing a new version of probes or you're doing new version of service, with either or both. There's the option to set up different monitoring boxes by using a different version, and then the thing in the backend will automatically deploy the version that you need. And then individual version can have different set of attributes. So for example, if you realize, oh no, my AMS probe needs another argument, then you release a new version, and then a metric definition that goes with that new version will be slightly different than the old one. And this, our experience was, this is quite important because people tend to improve things and then you need to release it, and then you have something which is running in production, so you can't really just roll it out and as my friend likes to say, plug and pray, right? So that's why we have the versioning. And we have the development instance, so you first plug it there, and then if it breaks, you don't care. So we have the versioning, There are many more of these things which I don't have time to go into, but because they are mainly important for us in the backend. But just to let you know, maybe you'll be another tenant in the future. So if you could drill down further, you will see there's a link to the repository and there's a link to the documentation. So all of these things are provided by the probe developer. Or if you tell us, oh, here's a really nice Nagios probe which already exists out there, we can always just link it to that one. Or the Nagios comes with the bunch of the Nagios plugins. There's a bunch of standard probes which we can install from the existing repo. This is also an option. We can always plug in something which is packaged and it's already in some existing repository. So basically, if you go down to the repo, we had a question recently, does the repo need to be formed in a certain way? No, it doesn't. So if you want to put, so for example, we do automatic builds in the backend with Jenkins, but it really, it's up to probe developer. You don't have to do it. We just want to get the RPM package from the YAML repository. But here's an example of okay, too much. Let's just show you metrics. So before I mentioned certificate validity. So for example, here we can see you can have different metrics coming out of the same probe. And then it basically their difference might be just one parameter that you pass. So in one case, you give them a port A, and in another case, you give them port B. So if I drill down a little further, so these things come from the package and probe. And then the executable, of course, I need to know the Nagios needs to know which executable to run. And then these config thingies are basically, for all of you from the Nagios world, you will recognize them. So it's timeout. It's always polite to implement timeout in your probes because we have runaway probes. If you're going to provide your probes, put the timeout in. Retry interval, and then the interval, max check interval. So all of these are basically parameters which tell to Nagios how often should the probe be run. So in this particular case, it will be executed every 24 minutes. I always forget if it's a minute or second. It's a minute, I think. Is it the check certificate? Yeah, it's a minute. And then retry interval is if it fails, give him a little bit of chance to recover before you say definitely if it's okay or not. These are hard and soft states. And max check interval, max check attempt. So if it fails 2 times, it failed. Then you just say, okay, this thing is gone, go back and fix it. User run and the path, these are basically where can I find the executable? And then we have these more things like parameters. So for each probe, you can send it a different parameter. There's our internal flags, and the attributes are also a mechanism which allow you. So for example, port, I'll have a better example, just give me a second. Portal check. This one has a port. No, it doesn't have a port. There we go. So in this case, the metric has an attribute called LB port. So this LB port can come from some other system. So for example, if you want to check if for some reason somebody is running a web server or Nova server or whatever server on a different port, so you don't have to put a static value for the port and then create a metric for each port that appears in your system. Instead of doing that, you put an attribute and then assign this attribute for a host, or you can just put some default one and tune it per host, and that way you can reuse the metrics. A bunch of details here. What is interesting basically for you is this part, because this is the part that we discuss with you when you come along and say, oh, this service is really important. Can I test it every 5 seconds? The answer, of course, gotta be no. But it's something which is quite, so for example, it makes no sense to check the validity of certificates every 5 minutes because it's not gonna expire in 5 minutes. So these are the things that we tweak in the procedure that I will describe at the end. Now, I'll just go back to the slides for a second. I hope this part is, there's a bunch of details if I, for a proper tutorial how to input all these things, I will probably take a week. So there's some facts. So right now we have 110 probes already in there, provided by different from other projects. Is that they can be so-called active and passive. In case of passive metrics, these can come from the outside world, so they do not come from the Argo itself. So, for example, the ARC or CREAM or SRM probes, they work in a way that there's a piece of code that you execute, and then this piece of code generates a bunch of different results, and you can basically register these results as a separate metric. So you just import them back into the system, and that way you can basically do higher resolution of monitoring. Say, for example, in the FTP example, FTP is an easy example for me at least. So you can say, I was able to open the connection, I was able to put something, but when I tried to get it, it failed. So you would say, you will have 3 metrics saying connect, put, get, and then only one of them would be critical if in case of error. So that it gives more information to people handling the service. Now the metric profiles. This is where the poem actually begin in the beginning. Begin with. So the metric profiles is the mapping between the service types. So you remember from the CockDB story, the Nova. So the mapping between service types and the metrics. So the idea is once you have the topology with a bunch of sites and NGIs and services, which are service type hostname, and then you have this metric profile, which says for these and these service types, you should run these and these metrics. And then you take all those details that I showed you before, and then just mangle it all together, and you will be able to monitor your world. So just to show you metric profiles, I'll just pick the most popular one. This is still, you can still see all this on these public pages. Going back to home, metric profiles. And the Argo mode is sort of a catch-all, and there's few of them which are old. We haven't removed them. So it's basically, let's put the portal here. So we have a portal here. So for example, EGI portal. So if I have a service which is checked, which is flagged as EGI portal, I should use these 2 metrics to see if it's working or not. And that's basically it. Mapping between service, we call it the flavor internally, while the CockDB people call it type. This is a legacy issue, but it's basically what you need to remember. This is a mapping between a service type and a metric. I should probably note down to change this in a nearby future. So these are metric profiles. We're going closer to reports now. The aggregation profiles. This is where we believe the Argo provides a bunch of value. Now, we came to a point where we know what to monitor. We know how to monitor it. We have the probes, we have the metrics, we have mappings between service types and metrics. Now, the question is, how do we aggregate the results? Because you do not, if you generate a report for EC review, you do not want to tell them, oh yeah, the certificate validity on a site A on a host name A.SRCE was good for the whole year. Nobody cares about that. You just care about the aggregation. So that's why we invented aggregation profiles. These things basically allow you to define how to group service types on a given level, and then how to group these levels between each other. You can also drill down further. You can define how do you want to group a metric, group your metrics, because I'm gonna switch back to the. It will be probably easier showing you directly. Switch back to the public view. So, for example, the EGI portal has these two things. Now, if they both go red, is it a red or is it green? So, these things really depend on the services, because in most cases it would be end. Basically, if the certificate is invalid, then the service is invalid. So a default thing, and we never had a different example, is that when you aggregate when you try to calculate the availability for this EGI portal service type, you would check the results for this and this one, and then you'll do operation end. Then going a little bit up, I'll just open the aggregation profile, and the critical, this is the one that we use to generate the reports. So here you can see what I was saying here. So how do you handle things between individual metrics? How do you handle between services of a given service type? And then these endpoints, how do you aggregate things if it's a site or if it's a service group? Let's say just stick with a site to keep it simple. Here you also define which metric profiles do I rely on, and then this is where it becomes interesting. So here, what I'm saying is, if somebody is providing, so here we create these service flavor groups. Service flavor groups. So each group contains several service types. So in this case, we have ArcSE, GRAM, QCG computing, HTC, Condor C. So these four things basically provide the same functionality, it's just with different service. So we put an OR, and when you calculate the availability of a site, what you would do is basically, if a site provides two of these, and let's say one of them fails, so you have one ArcSE and one ArcSE fails, but the GRAM continues working, and if the operation is OR, the availability would still be fine because the GRAM was working, and the users they were able to use your computing capability through a GRAM, but not ArcSE. So you don't care how they use it; you just care that they are able to use it. In which case you use OR grouping. So unfortunately, these other groups only have one service type, so I cannot explain that there. So, but in case, for example, that you have a portal, and then let's say, I don't know, like Confluence, you can put the portal, Confluence, and help desk, for example. In that particular case, you could say, oh yeah, these are my kind of tools, that you could call it group tools. And I care about all of them, and I would say that tools group is available only if all of them are available, and in that case you would change this OR to an end. So basically, when you define the aggregation profile, we can define infinite number of them. So all of these logical operations are tunable. So they would be used for different purposes. So we allowed you to group different things in a different way. So between the groups, there's again logical operation, and in this particular case, meaning that service is available if all of these are okay. So basically, if at least one of these and all of these. If the site does not provide any of these, then they are just ignored. In the calculation. So this is the aggregation profile. I'll have another example, which you will see how this whole operation business works like. And switching back to slides. So not only you want to aggregate things, ors and ends mean. So basically, and this is a really interesting part. So I said that we are using the Nagios API right now, and this is the only supported thing. But you could come up with a different system which uses I don't know, outage and not outage, and you could create an operation switch and non-outage, which defines how do you aggregate between those two things. And then you could basically reuse the rest of the system to calculate the availability and reliability based on a completely different inputs. We haven't tried this part yet, but these operations profiles, we are actually hiding them from the people. This is the first time I'm actually presenting about them. Sorry, somebody presented it before, but we were always kind of hiding it. But this is quite a powerful tool, which is still to be fully used. So finally, to wrap up the poem, as time goes on quite quickly, I want to show you how do you actually see the results. Now the reports. So this is what you get at the end of the month. This part I'll just show you here as I don't have that much time anymore. So a report, basically you tell to the system which topology to use. So what kind of so if is it aggregation of sites and NGIs, or is it aggregation? Oh yeah, I'll just show you live. It's more fun that way. I hope I'm picking the right one. Oh yeah, this is a fresh friend did it. Is it this tenant one? No, this is not the tenant one. Just give me a second. This was done like this week. Share. This is the reports. It's reports. Okay. So this is a development instance of Poem admin view. Unfortunately, you cannot get this view. Yet reports will be translated to public pages as a read-only as well soon. Now, here are the reports. We have a few of them. For example, we have the SLAs. I didn't talk about them that much. Wait, give me a second. I'll show you critical, just to be consistent. So for the critical one, you already saw the aggregation profile, you saw the metric profile, and now this is the report profile. So basically, you tell the system use this metric profile, this aggregation profile, this operations profile, and this is a bit where you basically filter stuff. So in the production report, you remember from the beginning, I want to monitor certified and production endpoints, and there's this scope thingy which is further filtering. And just give me endpoints which are production and monitored. The certification infrastructure is these are attributes of a site, and these are attributes of a service. And then you can further drill down. You can generate the report just for a given NGI or for a given site in principle. And this is where you can cheat. And where you can define thresholds for when you're green/yellow or whatever. So these are the reports. I wanted to show you the SLA. So these things use same information just in a different way. So they use grouping based on service groups, not sites. And then the scope allows us to filter the service groups which are in the SLA, and services which are production and monitored again. I will show you on the UI how all this thing looks like from the user perspective. And that's it. Oh no, that's it for Poem for now. Monitoring, this is backend story. I won't go into too many details. So there are two instances. This is basically Nagios in the backend. And these two instances are more they're completely the same. It's just one is sitting in Greece, one is sitting in Croatia. These things are, which is the requirement. So this up the changes from the topology, from the metric and all the other components, and spit out the Nagios configuration and kicks the Nagios to start monitoring new stuff or removes the old stuff. Now, there's also important bit here, and there's a whole story about the messaging, which is, I think we will organize a webinar for that, but that's a whole different story, which caters for different needs, not only monitoring, but since Argo provides the messaging service, of course, Argo uses it. It wouldn't be a nice picture for others if we would use something else. So messaging service is like a message bus, which is used for passing the results from Nagios boxes to the central computing engine. Now here there's this component with a long name. We just call it an AMS publisher. And this component isn't really Nagios specific. So you can pretty much use it for whatever. It consists of two things. One is a queuing, we call it a queuing mechanism, but in a sense, it's just one command which you use to store the results to a local directory queue. And that the publishing daemon is a Python daemon which just sits on these queues, and you basically say, listen to this and this and this and this queue, and then for each queue you can tell to the daemon where to publish the data. So in principle, you can have one of these guys sitting somewhere on a bridge and then publishing results for different tenants, for completely different systems, to completely different topics where a completely different listener is waiting for, and so forth. So this is something which kind of opens our story to the external sources, external inputs. So fortunately, this is something for a longer period, longer webinar. And a friend of mine is from Croatia is working on it. He's really keen on making it perfect as much as he can. The AMS publisher comes with a Python library as well. So basically you can just use the Python library if you already have everything that you need for using the messaging service. Enough about messaging service. Let's get to the central part. So this is where all the heavy machinery is. So we have analytics engine, we have real-time calculations, which basically translates to huge Hadoop cluster with a Flink jobs running, constantly calculating real-time statuses. I will not go into architecture of that part, but it is, as you can see, it's a really fat part of the factory. But I'll show you how it calculates things on an example. Basically, this data from the monitoring boxes, takes again the topology and profiles and just mangles it all together and spits out reports. So let's take an example with all that you've heard so far. Hopefully this will be easy to understand. So let's say we have service type called wiki. We have two services. Wiki has copy 1 and 2. As you can see, I stole this from a previous talk. And so reliability will suddenly become 100%. Availability is still 21, so 87 because you were not available. Now, So let's take the second one, and second one was okay for the whole day. So it was 100% and 100%. So now the availability reliability engine will constantly calculate availability for all of these metrics, for all of these services, and then aggregate it to a level of service type, and then aggregate it further up the hierarchy. So in this case, we had these two guys, and then let's say that operation between the metric is end. So when you summarize basically this guy, as you've seen before, this guy was unavailable for 3 hours, while this guy was available for the whole day. And then if I set for this particular service type, the operation between the individual services is OR, then my wiki service was green. So if you drill down, you will see that it was red on one of the endpoints, but then as a whole, it was OR. And when you generate the report for the site, the wiki service will have 100%. Now, I have 20 minutes left, so I'll just speed up a little bit. I'll show you the UI for all of you who haven't seen it ever, but I doubt it. Where's this going? Share session, store session. It disappears somewhere, so I'll just open this one, share, and then go to Argo. So this is a dashboard part of the UI. Cyril is the proud owner of this work. And then on the left side, you have some basic menu. This thing should be reasonably mobile friendly, but the dashboard just gives you a quick overview. So how the availability, reliability of the whole EGI was going in the past 30 days. Last statuses. So right now we have 440. To be honest, I'm not sure which one of these are. These are sites, I guess. No sites. We have 200 sites. So 440 is probably aggregated something. I apologize. I'm not sure what this thing is. You can come back to me. I'll find out. I'll ask you. So anyhow, this is the dashboard part. I do the backend part, so I'm really bad at presenting to you. I apologize again. So going back on the left side, so I'm showing you the results for DGI Critical, which is the one that I was showing before. So this is the one that you get in the email at the end of the month if you're a service owner. The NGI report will show you the availability reliabilities for past 4 months for each of the NGIs. So we are on a higher level. You can do the report out of it, do the export, or you can generate charts for every other country. Let me find my country. It's embarrassing. We're chasing down one site which just they cannot fix something. But from time to time, they remember to put the downtime. So that's why the availability is low and then the reliability goes up. Annoying. Now, sites report gives you similar overview just on a site level, and then you can do the filtering. If I manage to click it, you can do the filtering on the NGI level or based on the scopes. Same story, you can do the charts. Now, let me brag a bit. You have to give me a second to show you that we are not that bad. There we go, Fed Cloud. Working like a charm. Look at this. 100, 100. One would say, yeah, but you are running a monitoring. But if you followed my talk before, there is a second one in Greece. So even if I'm cheating on mine, I can't cheat both of them. Or can I? So going further, so these are the availability reliability reports. So this is interesting to show, to brag others, look how good we are. But then if you're a site admin, this one is more interesting. So this gives you a real-time statuses. So again, I can do a filtering of my own sites. So just give me NGHR. So these guys they still haven't fixed the damn thing. Sorry for that. And then you can go drill down and you see, oh, I have an OpenStack Nova and it's working fine. And then the OpenStack Nova has the instance. So here you can see the host name that I showed before, and then go drill down further and you see the individual metrics. So there are 2 metrics which are associated with this thing, and you get the individual. So this is what I said. So this is the status that comes on the exit of the probe. And this is the little bit further output, which tells you what the probe was doing. All right, but if it's okay, you don't really care. And then the metrics one, it's again interesting for operations. So let's say I want to see how a given metric is behaving right now in the world. So which one do I really care about? For the purpose of this talk, let's say I care about the SRM, cert validity. So you get an overview. 140%, 140 endpoints are okay, and there's 6 of them which are critical, 7 are warning. So this is like a for EGI. This was requested by the EGI operations. They wanted to get an overview. And then there's a custom report where you can further define what you want to get in your report, the timeline, and what kind of a report type you want. A recomputation is this is in case if the somebody messed up something. So somebody didn't update the CRL and the whole CA was gone and the whole country went black, and you don't want to say this was critical, you just want to exclude it from the report. So you can click there and say, oh, please go recompute for that and that period. So this is these requests are of course vetted, and there are specific rules in which we allow such things. And in that case, basically there's a procedure of recalculating. So what we do in case of recalculation, we just take the whole results of whatever you said that we should exclude, and we just exclude. And that's it for the UI. I have to leave you some time for questions. Share. So this was the UI. A bunch of interesting things. Please do send us feedback if you want to see some more things in there. Cyril is always eager to improve this part. And there's a web API. If you don't care about the pretty pictures, you want to get the figures straight out. There's the web API. I mean, this web API is used internally by us. It's kind of our internal source of truth. Because before kind of every component went out and fetched those sources of truth. Now we refactored it as part of the EOS Hub work, so that there's just one component that talks to the outside world. There's like a guy sitting at the entrance with a little notebook saying, oh, what do you want? Oh, that and that. And then this whole thing is translated into the web API, and then all the other components talk to the web API. Web API is available for the outside world as well. So you can basically get everything that you see in the UI from the API as well. So this is useful if you want to integrate these results into your own system. So this is basically how it looks like. For this, you will need to send a request because the access is restricted based on tokens. But there is an option basically to do all this. And then there are the alerts. This was also introduced a couple of years back. We use the emails that are declared in the GOG-DB. We also rely on the attribute if you want or not want to be monitored, which you declare in the GOG-DB. And then there's a bit of a logic here. So when are these alerts sent? So the alerts follow the logic of the aggregation profiles and availability reliability. So if you define that there's an OR between if you say, for example, I'm running several cream Cs and you say I OR between them, the alerting component will only alert you if your ANR numbers are falling. So it's basically if there's multiple instances, we do not issue alerts for them. At least not at this point. So the alerts completely follow the logic of the aggregation profiles that I described before. But so these are examples how you get a notification. So this part we are constantly expanding based on the requests. EGI. And here are bits and pieces on details that you get in the alerts. And going to for all of you who want to onboard a new service in EGI, So I put nice links to procedures. So first thing, before the stuff with the topology, sort out means you need to follow a well-defined procedure defined by the AGI people over the years. So first thing is you obviously you need to create a site if you cause everything to become red and a bunch of people to become unhappy. Now there's this integration procedure so that the monitoring team receives a new request. We check that the topology database is fine, and then we ensure that we take care of the poem. Those things is a bunch of attributes that I showed you. Those things are all defined by us with your assistance, of course. And then we deployed this on the devel instance, which we can break without any problems for production. And then if it runs well for a week or two in devel instance, we can just move it to production. We moved one probe for the EGI check-in like yesterday or day before into production. That part is really easy once you're happy with the results. Now, so here's we provided the guidelines for if you want to develop probes. So the guidelines basically point to different things. We try to keep ideas. We pick Nagios. Most likely that if you want to monitor something, somebody already wrote some probes, so which we can just plug in and start playing. So that's why if you don't see the probe in that repository that I showed you, and you really want to add it, you follow these guidelines. Now, Nagios Exchange is definitely a useful place to go. There's a bunch of stuff there. As I said, our repositories check if there's a probe which you can reuse there, or even better, improve so that the others can benefit as well. With regard to YAM repository, that's also not such a big deal because EGI provides the UNT, and so far we relied on basically people pushing stuff to the UNT. There's already a well-established procedure for adding stuff in the UNT. There's a bunch of people taking care of the UNT and signatures and all the other stuff. So that's all provided for you for free. It shouldn't be too difficult. I mean, packaging stuff also, it shouldn't be too difficult, but we already had a discussion with at least some of you there in the public that the packages won't go for you. So for that particular case, we're still discussing on a best option to go, because as I said, everything is automated and we can't do manual installations. And then this is kind of a circular probe development is fun because it involves us who know how the system work and how you can do the monitoring and what's reasonable. We have, if you are onboarding a service, we have you who understand well how the service should work. Then we have the EGI operations who will tell us how important is the service. And it's kind of a circular. We discuss, and then you propose something, we put it to development, we run it, then we break everything, then we go back and repeat like everything else in life. Finally, the one thing that you need to think about is how this thing should be grouped. You need to pick which services should be monitored. So if you need to generate new reports for that, this is something that needs to be discussed, of course, at the DGI level with the operations. We haven't had a situation where we added new reports so far. This might be a case down the line, because all the reports so far came from the DG operations. And then what I mentioned about the thresholds and weights, these are things that we can define, as I showed you. And then there's a bunch of documentation that you can try and see if it's up to date, and let us know if it isn't. And that's it. I thank you on behalf of Argo team. As I said, that's it. GRNET and CNRS. We have 7 minutes for questions.